Hello everyone and welcome back. So we are going to continue our look at solving rational equations. All right, and we're getting to more complex work here. So number 6 is actually very similar to how we did number 4. So if you want to go ahead and try number 6, take a look at number 4 and try number 6. Okay, you can pause the video and do it, but we'll jump right in right now. Okay, so right away I can see that we need to get common denominators here. Okay, this b plus 3, right, and this b minus 3, those are different. And then we have this b squared minus 9, which we know can factor. This actually becomes 10b minus 2 over b minus 3 times b plus 3. And so we need to get our denominators to match up here. Okay, so how can we do that? Well, I'm going to need more space, so I'm going to write it over here. So 7 over b plus 3 plus 5 over b minus 3 equals 10b minus 2 over b minus 3 b plus 3. Okay. All right, so then what do we need? Well, we can see since that b squared minus 9 factored to exactly the b minus 3 and b plus 3, okay, which we already have kind of over here, we can see that this denominator has these other two factors already in it. So we don't need to do anything to this denominator here. It's good to go. That one's good to go, right? But what is this one missing? What factor is it missing? That one is missing the b plus 3, so we need to put one there, right? So we'll do b plus 3 over b plus 3. And then what is this denominator missing? It's missing this factor. So we'll multiply it by b minus 3 over b minus 3. Okay, distribute the 7 to both terms there, and so we'll get 7b minus 21 over b minus 3 times b plus 3. And distribute the 5 there to 5b plus 15 over b minus 3 times b plus 3. And then here we still have the 10b minus 2 over b minus 3 times b plus 3. Okay, again, all the same denominators. In fact, let's go ahead and just combine these numerators together since they have the same denominator. So we'll just do this, and then this, and add them up. Okay, like so. All right, now combine like terms. So it's going to be 7b plus 5b is going to be 12b. And then minus 21 and plus 15, excuse me, is minus 6 over b minus 3 times b plus 3. And that's equal to 10b minus 2 over b minus 3 times b plus 3. Okay, multiply both sides by b minus 3 over b and b plus 3 to get rid of that denominator. So they're gone, and we have 12b minus 6 equals 10b minus 2. Okay, I'll put that up here. And now let's solve. Subtract 10b from both sides to get the b's together. So we'll have 2b minus 6 equals negative 2. Add 6 to both sides. 2b equals 4. Divide both sides by 2. b equals 2. Voila, there's our answer. If we look at trying to plug the b back in up here, we'll see that b plus 3 will not give us 0, 2 minus 3 will not give us 0, and 2 squared minus 9 will not give us 0. So b equals 2 should work okay. All right, let's try the next one here. All right, so here we can see we have x minus 6 and x minus 2, two different denominators there. And hopefully this will factor. Let's check it out. So we have 4 over x minus 6 and x minus 2. It does factor to the exact factors that we have right there. That's perfect. Okay, so why don't you guys, again, if you saw 6 now and you saw number 4 earlier, okay, try this one. Okay, I already kind of set you up, so again, you compare number 6 there and try and solve this one. Okay, hopefully you gave it a shot, or at least, got as far as you could get there. I'm going to rewrite it over here, leaving some space for myself. Oops, not equals there, and we'll say 4 over x minus 6 times x minus 2. Okay, so again, ask the same questions. It looks like this denominator already has the other two factors in it, so we don't need to do anything to this fraction right here. Okay, it's good to go. How about this denominator? What factor is it missing? It's missing an x minus 6. So we'll say x minus 6 times, or over x minus 6. Again, we're just multiplying by 1. Doesn't change the value, but it does change what it looks like. And then here, the x minus 6, it's missing the x minus 2. So we'll go ahead and multiply x minus 2 over x minus 2. Okay, distribute the 1. So it becomes x minus 2 over x minus 2 times x minus 6. Distribute the x. So we'll have x squared minus 6x all over x minus 2 times x minus 6. And then we still have the 4 over the x minus 6 times the x minus 2. Okay. So now, add these up, right? Combine like terms. So we're going to get x squared minus 6x plus the x becomes minus 5x. And minus the 2 all over x minus 2 times x minus 6. Equals then 4 over x minus 6 times x minus 2. Okay? They both have the same denominator now, so we can go ahead and multiply both sides by the x minus 2 and x minus 6. To kind of cancel out those denominators, whoop, whoop, and we get x squared minus 5x minus 2 equals 4. Oh man, they left us with a quadratic. How do we do this? Well, the first thing we can try is to see if it factors. But before we factor this thing, we need to make sure it's equal to what number over here? Not 4, right? It needs to be equal to 0. So we'll subtract 4 on both sides. We'll get 0 there, x squared minus 5x and then minus 6. Does this factor? It does. Okay, so we need two numbers that multiply to make negative 6 but add to make negative 5. What would those be? Pause the video and figure it out. It's going to be x minus 6 and x plus 1. Okay, set each of those equal to 0 and solve. X equals 6, x equals negative 1. Okay, now check your answers back. If you look up here, 6 is going to cause a problem there, isn't it? So we got to throw 6 out. It's extraneous. Does negative 1 cause any problems? Negative 1 minus 6, okay. Negative 1 minus 2, okay. And then if you plug negative 1 in there, you'll also be okay. Not equal to 0. So there's our only solution. All right? We'll stop there and take a look. Oh, that's our summary. So we'll stop right there. So in this lesson, we applied what we have learned in the past two lessons about addition, subtraction, multiplication, and division of rational expressions to solve rational equations. An extraneous solution is a solution to a transformed equation that is not a solution to the original equation. Right? It's an answer that you get, but if you plug it back into the original equation, it does not make the equation true. It makes it undefined or something like that. For rational functions, extraneous solutions come from the excluded values of the variables. We have to exclude those answers. Okay? And so there's your steps you can use to solve those rational equations. All right, thanks guys for watching, and we'll see you in the next lesson.